Let's solve the following linear inequality. So here we have 4x plus 3 divided by 2x minus 5, so that's less than 6. We'll begin by transposing the 6 from the right hand side to the left hand side. That will give us, we have 4x plus 3 divided by 2x minus 5 minus 6, this is less than 0. Now we'll combine the two terms on the left hand side. We'll have a common denominator, which is 2x minus 5. And in the numerator, we get 4x plus 3 minus 6 times 2x minus 5. So this is going to be less than 0. Let's solve the numerator. We have 4x plus 3 minus, so 6 times 2x will be 12x. Minus 6 times negative 5 will be positive 30. Divided by 2x minus 5. So this is less than 0. Now, 4x minus 12x, that gives us negative 8x plus 3 plus 30 will be 33. So this is divided by 2x minus 5 less than 0. If we take negative as the common factor, we have negative of 8x minus 33 divided by 2x minus 5 less than 0. The only reason we are doing this so that we can make the coefficient of x in the numerator positive. Now we will multiply both sides of this linear inequality with negative 1, but before doing that we'll have to be wary of the fact that if, let's say, we have a less than b and we have another number c which is negative, that means less than 0, then it follows that if we multiply a with c and b with c, then in that case the sign of the inequality changes and we'll have ac greater than bc. Using this property, when we multiply both sides of the inequality with negative 1, we will have 8x minus 33 divided by 2x minus 5. So this will become greater than 0. Now we'll have to find out the solution to this linear inequality. Solving this linear inequality is the same as solving the original linear inequality. Now we'll have two cases. So we'll start with case number 1. So here case number 1 states that we have a rational expression 8x minus 33 divided by 2x minus 5 and this value is greater than 0. This would mean that if we consider the numerator, which is 8x minus 33, to be a positive number, and we also consider simultaneously the denominator as also a positive number, in that case then we have a positive number divided by the positive number which will make it positive, that means greater than 0. And let's solve this. So we have 8x is greater than 33 and we'll divide both sides with 8. So we have x is greater than 33 divided by 8. And we have 2x greater than 5 and we'll divide both sides with 2. So we have x greater than 5 over 2. So let's find a solution to this. So for this we will draw a number line, and on the number line we'll have the value 0. So here we have 5 over 2 and we have 33 over 8. So 33 over 8, that's greater than 5 over 2. That's why we put it to the right of 5 over 2. Now the first one says that x is greater than 33 over 8. So that means we'll have to consider all the values of x which lies to the right of 33 over 8. So this is going to be the solution. It extends all the way up to positive infinity. And the second one says that x is greater than 5 over 2. So we'll take all the values of x which is greater than 5 over 2, or it's going to lie to the right of 5 over 2. We have to find a common solution of x which satisfies both these two inequalities, and that is going to be given by this common region. So here this common region simply means that we have x greater than 33 over 8. So this is what we have obtained from case number 1. Now we will discuss case number 2. So case number 2, we have 8x minus 33 divided by 2x minus 5, which is greater than 0. That would mean that if we consider 8x minus 33, the numerator to be a negative number, and simultaneously the denominator to be also a negative number, that is less than 0, we have negative number divided by negative number, which makes it positive, and this inequality will hold. So solving these two inequalities, we have 8x less than 33 and 2x less than 5. Or we have x less than 33 over 8 and x less than 5 over 2. Fine. So let's find a solution to case number 2. So here we'll consider the number line. On it we'll have 0, 5 over 2 and 33 over 8. We'll have to consider all the values of x which is less than 33 over 8. That means all the values of x that lies to the left hand side of 33 over 8. So it extends all the way up to negative infinity. And we have to consider also the values of x which is less than 5 over 2. So that means it's going to lie to the left hand side of 5 over 2. The common solution to both the two inequality will be this common region from negative infinity to 5 over 2. So that means values of x which is going to be less than 5 over 2. So from now we have two solutions from case number 1 and case number 2. Both of them are equally valid, so we will combine these two solutions. To do that, all we have to do is consider the number line. Here we have 0, 5 over 2 and 33 over 8. Now we will take from case number 1 all the values of x which is greater than 33 over 8. So that means it's going to lie to the right of 32 over 8 and extends all the way up to positive infinity. And from case number 2, we have to consider all the values of x which is less than 5 over 2. That means solution lying to the left side of 5 over 2 and extending up to negative infinity. So this is the solution. And if we want to write it in the interval form, also referred to as the solution set, so that will be, we have solution going from negative infinity to 5 over 2. So this is going to be an open interval. That's because 5 over 2 is not a part of the solution and negative infinity is unbounded. This solution holds, this means it satisfies the linear inequality. And this is also another solution which also satisfies, that means, or we can take the other interval which is going from 33 over 8 to infinity. So this is going to be the solution to our given linear inequality.